Hi, welcome back. So today we are going to continue to study how derivatives affect the shape of the graph. Right? So before this, we have already learned that the first derivative test will tells you about the shape of the graph. Sorry, not the shape of the graph, it's about the slope of the graph. Right? So we know that if we have your first derivative greater than 0 or a positive f prime x, you are going to have an increasing graph, right? Or your graph is going up. But if you have a negative f prime, you are going to have a decreasing graph, or your graph is going down. So now we would like to study the behavior of the graph for a certain interval. We want to know which part of the graph is going down, which part of the graph is going up or increasing. Right. So first example is given this function fx equals to 5 minus 3x squared plus x cubed. Now question asks to find the intervals on which f is decreasing or increasing. So first step to solve this kind of question is to find the critical point. Right? In order to find the critical point, we need to find the derivative first. Right? So we know, so we start with fx equals to 5 minus 3x squared plus x cubed. So the first derivative f prime x equals to, first the derivative of 5 is 0, no need to write. The derivative of negative 3x squared is negative 3 times 2 equals to negative 6. X power of 2 reduced by 1, going to end with x plus 3 bring in front, and x cubed reduced by 1 become x squared. Right? So now finding the critical point negative 6x plus 3x squared, let this equals to 0. So factor first, so we get 3x factor negative 2 plus x equals to 0. So from here we get our critical point is when x equals to 0 and when x equals to 2. Right, negative 2 plus x equals to 0, we get x equals to 2, and 3x equals to 0, we get x equals to 0. Right, so now once we have our critical point, what we need to do is we put them on the number line. Right, so we make ourselves a number line, 0 and 2. Right, so based on this number line, we have our sections of the graph. We can divide them to certain integrals. Right, the first section, the interval of the first section is from negative infinity to 0. The second section, right, so let's name our section. This is our first section, second section, and the third section. Right, so the second section would be from 0 to 2, and the last section would be the interval from 2 to positive infinity. Alright, so we're going to pick a number within this interval, and we are going to substitute inside f prime x to see whether it's positive or negative. Right, so we're going to pick an x naught. Right, so one number inside this interval So let's choose -1, and our f prime x naught, if we substitute -1 inside, here, you're going to have negative. Substitute -1 inside here, also we are going to have negative. Negative times negative are going to give you positive. Right? Now let's try this one. Pick a number between 0 and 2. We are going to go with number 1. So substitute 1 inside again. Substitute 1 inside here, we're going to end up with 3. Substitute 1 inside here, we are going to end up with -1. So positive 3 times -1, we are going to get negative answer. So we denote this as negative. And the last section, or the last intervals, we are going to choose number 3. Right? Substitute 3 inside here, we are going to get a positive. And substitute 3 inside here, we are going to also get a positive. Positive times positive is positive. Right? So based on our explanation just now, a positive f prime means the graph is going upward or increasing. Right? So right here, this is increasing, this is decreasing, and again increasing. Right? So we write our conclusion here is that fx is increasing at interval -infinity to 0 and 2 to infinity. Right? And decreasing at interval 0 to 2. Okay.